Hello guys, welcome back to Programming Programmer. So today we are going to see the solution to the problem B jumps. Okay, so this question is from Codeforces Educational Round 99. So let's see what the problem says. So the problem says to us that we are standing at position 0 on x-axis and you can make several jumps. Okay, so we need to make several jumps so that we can we need to reach position x. Okay, so we will be given position x, so we can make several jumps to reach position x. So there is a rule to make a jump. Okay, so the first rule is, if I am on my jth jump, so if I am on my kth jump, I am jumping for the kth time, and I am on position y. Let's say I am on position y. Okay, then the distance that I will cover in my jump would be y plus k. Or the second condition will be, if I am going backward, okay, then how will I do the jump? I'll just do y minus 1. Okay, I am at a position y, I'll just go a step back if I am going to jump backward. Okay, so I can jump forward as well as backward, but for jumping forward, the rule is, if I have performed k jump, if I am performing kth jump, then if I am at y, then I will jump to the point y plus k. Okay, and the distance that will be covered in that jump will be k distance. Okay, so my new position on the x-axis would be y plus k, and if I am jumping backward, then I'll just take a step backward on my x-axis. Okay, so what is the minimum number of jump we need to make so that you can reach to point number x? Okay, so these are the constraints. T is from 1 to 10 to the power 3, x is from 1 to 10 to the power 6. So I'll just link this problem in the description box. Let's see how we are going to solve this problem. So for the beginning, I want to say that this is a fairly observation based problem. Okay, observation plus mathematics based problem. So let us see what observation we can make here. So let us say I am at my 0th jump. If I am at my 0th jump, then I will be at position 0. So I will be at position 0. I have done 0 jumps and I am at position 0. Now let's say that I will perform my first jump. Okay, so for the first jump, what position I can take? I can take position as 1. Okay, for it will be 0 plus 1, 0 plus 1, and the another position that I can take is minus 1. Okay, that will be 0 minus 1. Okay, now if I am jumping for the second time, okay, so I will be on either of these position. Okay, so let us say I am at this position. Okay, so if I am at 1, then the new position that I will take is, if I jump forward, will be 3, and the new position, if I jump backward from 1, then it will be 0. Similarly, for minus 1, it will be, I'll jump 2 step forward, so it will be 1, and if I jump backward, then it will be minus of 2. Similarly, you can calculate for 3 as well. So for 3, like I am at 3 right now, so if I jump forward, then will be 6. If I jump backward, it will be 2. If I am at 0, then I jump forward, then it will be 3. If I jump backward, then it will be minus 1. If I jump forward from 1, then it will be 4. Similarly 0, then from minus 2 it will be 1 and minus 3. So these are all the position that I will assume on a particular jump. So let's do an observation here. Let's do a quick observation here. So what that quick observation will be, so for 1, let's sort this, what I am having here. So after sorting it, what I will see is, I will get minus 1 and 1. For 2, after sorting, what I will get is, I'll get minus 2, 0, 1 and 3. For 3, after sorting, what I'm going to get is, I'm just going to get minus 3, and then after that minus 1, then after that 0, then after that 1, 2, 3, then 4, then 6. So these are the new position that I am going to assume. So according to question, the x that we will be given will be greater than 0. Okay, so it will be greater than 0. So excluding 0, I am gonna take all the terms. Okay, so why I am doing this? So I need to calculate the minimum number of jumps. Let's say if we are given x as 1. Okay, if we are given x as 1, then the minimum jump will be 1. If I am given x as like I have already calculated for 1, so here the new value will be 3. If I am given x as 3, then my answer will be 2. So I have already done for 1 and 3. Now let's say that I am given 2, I am given x as 2, then my answer for 2 will be 3. Okay, so you can also see that it is in the sample test case, the answer for 2 is 3. So you can calculate yourself. So let's do one thing, just take the positive terms. We are only concerning about the positive term. So now after doing this, you can see here is a pattern. Okay, so the pattern is the pattern will be visible from actually it will be visible from 2 onwards. So the pattern is for the very first I am taking 1, then I am skipping 2, then I am going to 3. Now for 3, what I am doing is I am taking 1, I am taking 2, 3, 4, I am skipping 5, then I am going to 6. Okay, so how can we do this? How can we make our fourth jump very easily by this data? Okay, so see carefully, the maximum term that I am having here is the maximum term that I am having here plus 3. Okay, maximum term that I am having here plus 3. Okay, so it makes sense. Okay, so what so the best thing that I can do while jumping is I'll just make progressive jumping. Okay, so I am at 0, then I will go to 1, then I'll make I'll make progressive jump of 2 forward, then I will go to 3, then I'll make a progressive jump of 3 forward, then I'll go to 6. Okay, so 0 1 3 6. So what it is exactly, I will say now I am at pth jump. Okay, so for pth jump, what will be the maximum value? Maximum value will be 1 plus 2 plus 3 plus 4, 1 plus 2 plus 3 plus dot 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 till p. Okay, so this will be for pth jump. Okay, so now for fourth jump, what will this be? It will be, the maximum term will be 4 plus 3 plus 2 plus 1, which will be 10. Okay, so now starting from 1, I'll just going to skip this part from now onwards, and I'll just going to write for 4. So it will be 1 2 3 4 5 6 7 8, skipping 9 because we have to skip the term just lesser to the maximum term. Okay, so the maximum term will be 10 here, so I'll just take 10. Okay, now this was the observation till now. Okay, so this observation must be clear to you. So we can make 5 6 7, we can make any terms. Okay, so we need to do one more observation. So what will be our one more observation? Like here I am getting the new term as 1. Okay, 1 is already found. Here I am getting new term as 3. Now 3 is already found and 1 is already found. So 1 is already found, 3 is already found. So what I am getting as my new term? 2 4 6. Now check for 4. 1 is already found, 2 is already found, 3 is already found, 4 is already found, 5 is new, 6 is already found. Yeah, 6 is here, 7 8, then 10. Okay, so now what is my observation is, for this observation you have to see from here. Okay, so we started generalizing from here, now we need to generalize from third term. Okay, so from third, what we can see, what we can observe is, like for third term we are getting exactly 3 new values, right? For fourth term we are getting exactly 4 new values, and there is also one more pattern in these values. What? Like for 3 I am having maximum term, then I am just skipping one term, then I am having this term, then I'll just go and before finding the last term I'll just skip one more term. Okay, similarly here also 10, I'll skip 9, then I go to 8, then 7, then I have my count at 3. Okay, so now I'll just skip this term and I'll go to 5. Okay, so now based on this observation, let us tell what will be the output for 5. Okay, so we need to calculate from here. So for 5 the maximum term will be 1 plus 2 plus 3 plus 4 plus 5, which will be I think 15. Okay, so it will be 15, so I'll just write 15 here. So my 15 is new term. Other than 15, what my new term will be? I'll just skip 14, so I'll just go to 13. My new term will be 13. What will be my another new term? My another new term will be 12. Another will be 11. See, I have already reached 4 terms. Okay, now I'll skip one more term, that will be 10. Then my new term will be 9. You can verify it yourself that these are the terms that have not come till now. Okay, so this is the pattern that we got here. Okay, so from this pattern, what we can see? We can see that we are skipping a term here, and we are getting our terms for a jump number. We are getting the terms. Okay, so now what can I say is, if my x is 15, my answer will be 5. If my x is 13, my answer will be 5. If my x is 12, answer will be 5. 11, answer will be 5. 9, answer will be 5. But we need to do more optimization here. Okay, so here is one more problem. Okay, so we are going to just do it in order 1. Okay, we are just going to go solve this problem in order 1. How we are going to do that? Let's say that our maximum term, that let's say that my jump is p. Okay, let the jump number be p. Okay, so for jump number p, what is going to be the maximum term? The maximum term is going to be p into p plus 1 divided by 2. How? Actually, this is like we are having 1 plus 2 plus 3 plus 4 plus dot 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 p. Okay, so this whole is equal to this. Okay, so it is called sum till n terms. If you don't know about this, how you get this, then I'll definitely I will for your help, I will post some material in my description box, so you can see that, you can refer to that, then you will be clear about how we are getting this fundamentally. Okay, don't worry about this, just know that it happens. Okay, sum till p terms will be p into p plus 1 divided by 2. Now what we are going to do is, let's say the user gives us x. Okay, user just give us some x. Now what we are going to do is, we are just going to equate it to p into p plus 1 by 2. So if I multiply p into p plus 1 by 2, I will not multiply, I am just writing it equal to x. Now if I simplify this equation, what this equation will become? This equation will become p square plus p minus 2x equal to 0. Now we can find the solution of this equation by Sridhar Achaya formula. So Sridhar Achaya formula is, you must be knowing it, you must have studied in class 10th. So that is, the solution for this equation will be minus b plus minus under root of b square minus 4ac divided by 2a. Definitely our answer will be going to positive, so I'm just going to take minus 1, so minus b plus under root of I'll just show you what you will get after writing in this form. Okay, so I'll just link Sridhar Achaya formula also in the description box. My teacher used to tell me that, tell us that it is Sridhar Achaya formula. So from that time we all speak that it is Sridhar Achaya formula, but I don't know that whether it is or not. So I'll just verify it after the video. So I'll just link that also in description box about the Sridhar Achaya formula. And let's see that what we are going to get is, we are going to get 1 plus 8 into x minus 1 divided by 2. So our valid solution from Sridhar Achaya formula for the above equation will be this. Okay, so this is the thing that is going to solve this problem in order 1. Okay, so now just take out your calculator. Okay, I also did this thing. Just take out your calculator, and in Sridhar Achaya formula, put 15. Okay, sorry, in this formula put 15. When you will put 15 in this, okay, you will get answer of 4.8 something. I think it will be 4.8 something. And what I am going to do is, I am just going to take the seal of this value. Okay, so if I am going to take seal of this value, then I am going to get 5. Okay, so for 15, 13, 12 and 11, we are going to get what our answer? Our answer will be 5, okay, by taking seal of this. So what is our final answer? So our final answer will be like, I'll just take it in bracket and I'll just write it seal here, okay. So seal is a function in C++. So seal of this value will be the answer in order 1. Now there is one problem, like I am getting the correct answer for these 4 values, but I am not getting the correct answer for this value. And this is a similar case for 4 also. For 4 also I am getting answer for this, but for this I am getting answer 3. For all these I am getting 4, but for this I am getting 3. Similarly for this also, okay. So let's see what series this is. So in this series we can see that we are having initially 2, then 5, then we are having 9. So let's write it here. So our series is 2, 5, 9. So we are very near to the solution, but we need to find what this series like what is the nature of this series. If we are able to find the nature of this series, then we can definitely tell what will be our answer. Why? Because if we know what the nature of the series is, then we can predict the terms that will come after in this series. And if we know that, then if a user give an input of that term, then what we are going to do is we are going to just do answer plus 1, okay. So let's find out what this series is. So when I observed this series, what I got is, if I write 3 above 2, 4 above 5, 5 above 9, okay, then I can get the terms next, okay. So how I am going to get the next terms? Let me just show you. So the next term in this series will be 5 plus 9. What is 5 plus 9? 5 plus 9 is 14, okay. Now I am going to write 6 above. Now the next term will be 20, okay. 14 plus 6 equal to 20. I am going to write 7 here. Now you can just have fun with it, okay. So you can play around with this and you will get what this series is. So this series looks something like this. I'll just sum these two values, it will give this. I'll just sum these two values, it will give this. So this is how I am going to map this series. Actually this is not mapping exactly, but this is how I will pictorially visualize this series, okay. So this is how we will proceed in this. Now going further, I know the terms in my series, okay. I know it is 2, 5, 9, 14, 20. Now exactly what I am going to do is, I am just going to take a set, okay. There is a function, there is a STL in C++ which is called set. I am just going to take set, and what I am going to do is, I am just going to save these numbers in set, okay. 2, 5, 9, 14, 20, okay. In set the find operation is in order of log n, okay. So initially if I maintain a set, okay, so my x is maximum value for my x is 10 to the power 6, okay. So I'll just run a for loop. So I'll just run a loop, okay, not for loop. I'll just run a loop, so that I'll just choose this operation, and this will do it in order of n, and I am just going to maintain a set of these values, okay. So this will be order n operation, and we are not going to get TLE because we are just pre-processing this data beforehand, solving the problem before we are even taking the t-test cases. We are going to do this, okay. So this will be in order of 10 to the power 6. We will not get TLE. Then I will maintain this set, and what I am going to do is I'll take some x from the user. When I am going to take some x from the user as input, then this will be my answer, okay. So my answer will be seal of, let me just write it down here, answer. My answer will be seal of under root of 1 plus 8x minus 1 divided by 2. This is going to be my seal value, okay. So what I am going to just do is, I am just going to check whether my set is having, like whether my x is present in set, that will be in order n, okay. So I am just going to check whether this is present in my set. If it is present in my set, then what I am going to do is, I am just going to return answer plus 1 as my answer. If it is not present in my set, then what I am just going to return, I am just going to return answer. So it is this simple. Okay, so let me summarize the whole problem. What we did is we just we started observing what will be for one jump, what will be for two jump, three jump. Then what we did is we observed that we are only having positive values, so we just concerned about positive values. And this is how we are just like observing this problem. We just observed that there is a portion in the series which is having a gap of 1, and that is also making some abnormality in my series. Okay, in abnormality in my answer. So what I just did is I just stored the set of those numbers by finding out what the nature of those number is. Okay, this was done in a hit and trial process. Okay, so I did this, and what at the end I got is, if that number is present in my set, then my answer will be answer plus 1, otherwise my answer will be answer. Okay, so let me just show you the code that I did for this. So the code is like, this is my main function. I just pre-processed this. Okay, so this is my pre-processing, and I declared my set here. I just made a global set, and what I did is I just took I just called the solve function. Inside solve function I just inputted x, and after inputting x, this is the part where I am calculating my answer. So it is fairly simple calculation, you can get it by your own. After calculating the answer, what I did is I just tried to find out whether it is present in my set. If it is present in my set, then my answer would be answer plus 1. Okay, if it is not present in my set, then my answer will be answer. So this was the solution of this problem. If you like my video, if you feel that my video was helpful to you, then do like, subscribe and share this video. Thank you.